The Beef CSE has been researching the effects of different breeds and within breed selection on a range of traits from growth through to carcass, including marbling. Research leader with the New South Wales DPI, Bill McKiernan, describes the trials he's been involved with and some of the early results.
The area that I was concerned with was a project called Regional Combinations. And the project involved 4 sites across southern Australia, from Western Australia, South Australia, Victoria and southern New South Wales. And the aim of the project was to look at various genotypes, including different breeds and crossbreds, under different growth regimes in those environments. And basically to study the effect of those production systems to meet market situations that were appropriate to those particular areas. Now the results of that, after 7 years of experimentation, we used something like 8,000 cows. We produced in the order of about 2,500 to 3,000 steer progeny that we could study at those various sites. And in doing that, we found that growth path had a substantial effect on the animal's ability to meet market specifications. It also had a small but significant effect on the eating quality of those carcasses at the end of the day as well. And basically the faster grown animals generally perform better. And although that was important, but the difference was only small. There were significant differences between the genotypes of those animals. Those animals that were selected for high intermuscular fat, or marbling, and those compared to those animals selected for high yield, there were substantial differences in their eating quality. The high yield types still ate very well, but not as well as the high intermuscular fat types, and which really is what you'd expect to see.
This experiment used 5 breeds of sire. Both red and black Wagyu were used to represent breeds with very high marbling potential. Charolais and Limousin represented the high growth and yield breeds, while Angus represented the moderation of the British breeds. Within the Angus, 3 lines were selected representing within breed differences for yield and marbling, or as it's sometimes called, intramuscular fat. High-yielding Angus sires, labelled high RBY percentage in this slide, were selected using EBVs for retail beef yield, that's retail beef yield percentage. High marbling Angus sires were selected using EBVs for intramuscular fat percentage, or IMF, while the third line were sires that were relatively high for both traits. All sire breeds were mated to a random sample of Hereford cows to ensure the female contribution to the progeny performance was equal.
Now the results across all of those sites was fairly consistent, and that in itself was an important result, because what it said to us that no matter where we compared these breeds or types, or no matter how they were grown, fast or slow, the animals performed exactly the same under each of those regimes. So there was no interaction between breeds and types and growth components, which is really important, because that means we can be very confident in the prediction of how genotypes will perform under various conditions, and they'll perform the same all the time. From those animals selected on EBVs, for example, it's a really important result in that select animals for high intermuscular fat under these sorts of conditions, they'll perform in a particular way, and even under other conditions they'll still perform in that same way in terms of ranking. So that was a really, really important result. The second good result was that those sires selected for differences in intermuscular fat and yield produced progeny as they would be predicted. So the result from selection based on EBVs resulted in progeny that you would have expected to occur. So those bred for high intermuscular fat had, or those sires selected for high intermuscular fat produced progeny with high intermuscular fat. Those sires selected for high retail beef yield produced progeny with high retail beef yield. And really nicely, those selected for both traits, which we know that the two traits, yield and intermuscular fat, have got a negative correlation. So generally if you select for one, the other one will go in the opposite direction. But we can, through things like selection correctly for EBVs, on things like using breed object, for example, we can actually select for two traits, although they're negatively correlated, and get positive response in both those traits. And that's exactly what we found within this experiment. We found that the resultant progeny by those bulls that have been selected for both traits, in fact, were sort of midway between the two groups of progeny selected for each individual trait. So that was really positive, and it meant we could move forward in selection in those areas. Just the other important trait from a crossbred point of view was the fact that the Wagyus performed as you would expect in terms of increased intermuscular fatness in their resultant progeny. However, their growth rates weren't quite as good as some of the other breed types. And the European types obviously performed very well in terms of retail beef yield, and better than what you'd expect from the British type. So there was a distinct advantage there too. I mean, the other main impact, of course, too, was that those high growth European types produced progeny of high growth, as well as high meat yield, and with a resultant end product that had sort of quite substantial advantage in total beef produced, which is consistent with other research that we've had in the past.
So how would a producer apply the information from these trials in setting up a crossbreeding program?
You can apply this information in relative to the designed breeding program that you're on, looking at the type of market that you're trying to get to at the end of the day. Obviously, if you're looking for a high quality, a high fat endpoint, then those types of animals, Wagyu and animals selected for high intermuscular fat, for example, will produce those sorts of animals. And if you're looking for high eating quality animals as well, and one of the component of this experiment was that we actually ate in the New South Wales site all of the progeny, and so we tested their eating quality, and we found that those high fat types actually ate better than the high yield, low fat types. But when they were tested on an MSA grading system, there was no difference between the two. So effectively the high yield types were still eating quite well, but not as well as the high fat types.
Would the high yielders be younger?
The design of the experiment looked at the animals was all produced from AI, and so the animals were born with a very short period of time. And the analysis took account of the fact that there was some little age differences, and so we accounted for that. They were slaughtered at exactly the same time, after the same amount of time on feed and so on. So conditions were exactly the same. And as you'd expect, the high yield types were leaner. They had advantages in performance in terms of growth rate and yield, but they had disadvantages in terms of their actual eating quality. And so it really points up the fact that you design breeding programs with combinations of animals based on the market that you're heading for. So if you're heading for a high quality market that requires high levels of intermuscular fat, then there are some types that you would go for. If you're looking for a market that requires high growth and leanness and reasonable eating quality, then there's many of these European types would suit that bill.
So being more specific, if you had a magic wand, what are the breeds you would use to set up a program targeting the EU market?
Well, the EU is a really good example of how we could apply this information. The EU market is it requires Heavy carcasses at a relatively young age, so they're looking for something in the order of a 350 60 kilogram carcass with less than 4 teeth or less. So it means that those animals have got to grow fairly quickly during their lifetime, and you want genotypes that are capable of achieving that weight in that period of time. So the EU market also requires not a great deal of fatness. So there's no requirement, for example, for intermuscular fatness, but there is a requirement for subcutaneous fatness in the order of 7 to 17 mils of fat, which is not that fat. So a crossbreeding system that's set out to have high growth with reasonable eating quality, with not a lot of fatness, as long as they reach that 7 to 17 mils of fat at the required weight, would be the way to go. And given our results from the regional combinations project, you could look to having a crossbred cow or even purebred cows terminally sired to European bulls to achieve those sort of growth rates and market specifications quite easily.
Is it important for a crossbreeder to use EBVs when selecting a bull?
It would be, and where EBVs are available, so things like the Shorthorns, the Herefords, the Angus, they've got good EBV figures available, that you can make selection of your bulls for those traits that you're looking for, whether it be in an EU market where you're looking for high yield and high growth, or whether it be for a fatter market, a longer fed Japanese feeder steer, for example, you're looking for high intermuscular fat. EBVs gives you a big advantage in assisting the selection of those bulls. There are some breeds, some of the European breeds, for example, at this stage haven't been actively progressing selection based on EBVs, and that in fact is a deficiency within those breeds. It makes it difficult to go to some of these European type bull sales and select the sort of animal that you're after, because we found within our experimentation that those types of animals have got high yield and high growth, but wouldn't it be lovely if we could select that same animal with a little bit more subcutaneous fat or a little bit more intermuscular fat to improve their eating quality? Those sorts of things. And the only way we can do that is the utilisation of an EBV technology.